Well, welcome to the shop. It's in shambles. So the shop of shambles is here for you, and it's a good time. It's the shop is in shambles because I have been a very busy bee. I'm working on 4 projects. Yeah, I am working on the PT-19. I'm working on doing some additional work on the P-26, the pea shooter, and more on that later. And of course, the Model 44, trying to make progress on that. But the big progress that I've been able to make this week has been a project for my friend. I haven't mentioned his name, and I'll continue not to do so to respect his privacy. But I do want to share his big project with you because, wow. All right, so I'm more or less ripping off the Band-Aid here. So as you can see, this is by far the largest airplane I've ever had in my shop. It's absolutely massive. Kind of hard to see because of the perspective. But so yeah, here's my bench that I'm normally working on. Here's the 19. It's just so massive. It's so massive. So what is this? This is the Legacy Extreme Flight Muscle Bipe. So this is basically a Waco. We're not going to get into that debate. Platform that is just a stunning example of an airplane. So what you're seeing is truly about a week's worth of work. What did we accomplish? Well, everything you see here. Massive box, as you can see, just stuff stacked everywhere. But we got the landing gear mounted, and not only that, there are these little spats you have to glue in, and then taking care of wheel pants and wheels and axle and all of that stuff, making sure that you have appropriate clearances and Loctite and epoxy, etc. It's a thing. Additionally, we got the struts mounted. That's just a couple of bolts, but I did not do Loctite in any of those just yet because we have to put the servo extension wires up through the struts, and they have to have shrink tube put over top. So the shrink tube is coming so that we can accomplish that, but that's why that has not been completed yet. So additionally, the rudder, if you can see, so there's a sandbag on the tail to make the tail heavier so that it'll actually stay on the ground, because we'll get into what's in here soon. But yeah, the tail is pretty much taken care of with respect to everything, almost. We got the tail gear installed, and just to bring you up into frame, this is how the steering is accomplished. It's just through the rudder. It's linked from the rudder to the wheel. So all of that is installed, Loctite in place, good to go there. And then the rudder was installed using epoxy, 30-minute epoxy, and cleaned up with my isopropyl alcohol, because that's how you clean up epoxy. I still have yet to install the horns, the control horns, and install the pull wires. That is the last thing left, but I do have the servos installed. Let me get the hatch open and just open things up in general. There's actually 2 hatches. There's the hatch with the pilot, and then there's a forward hatch. I'll explain. There's a reason why. All right, hatches 1 and 2 removed. So we have all of this space open all the way up to the firewall. All right, so we've got our MKS rudder servo. This is an MKS HBL 3850, like 700 ounces of torque. Absolutely massive servos. You have to do servos like this on a plane like this. So there's additional mounting for power inputs. There's a secondary servo where you can link 2 rudder servos together so that you can get more torque if you're going to fly this like 3D aerobatic stuff. The guy I'm building this for doesn't do a whole lot of that, so we're not going to do that. This should be adequate for the way that he flies. Down here we have quick releases for the bottom wing, which is really nice. So once the wing goes in with the tube, and it just locks automatically, and then pull out and up, and it releases. Really nice. I did lubricate those a little bit just to make them more smooth in operation. So up here, yeah, here's the mounts for the struts. Pretty straightforward, pretty easy. But like I said, we need to work on those a little bit more. The engine that he's having me put in requires a pump. This is a fuel pump. The way that this works is fuel goes in here, and the correct amount of fuel goes out here, and then this is a return line that goes back to the tank. Okay, and so that way you maintain an appropriate amount of pressure, but this is also nice because you plug it into your receiver, and then you can put it on a curve so that it increases the amount of fuel throughout your throttle curve, and you can adjust that. Pretty nice. Throttle, same servo as the rudder, so it's way overkill, but I needed to mount it in a different location than what is recommended from the factory because different engine. So DA 200 is what is recommended here. 4-cylinder, flat 4 engine, and that is not what we put in the note. So at this point, I've pretty much covered everything that I've done to the plane so far without taking the cowl off. The engine cowl I also had to mount. It's pretty straightforward. It's just a few bolts. It's molded very well. This is a very high quality model, but I did have to cut holes in it. And that's for the exhaust and for the choke. So 2 holes I had to mark and then cut. And you guys know the drill. You've been on my channel before. I've worked with composite stuff before. You make sure that you tape the painted side, and then you drill a pilot hole in the center, and you work your way out. And you don't try to cut. You try to simply remove. I used a carbide bit at first, and then finished off with a sanding drum. Okay, that way you don't chip the paint, and everything stays looking really nice. So I'm going to put the 2 hatches back on, and then I'm going to take the top of the cowl off, so that way I can show you the business end of this insane model. And this is the business end. Welcome to the business end of the 110-inch wingspan Muscle Bipe. Okay, what we're looking at is a UMS 7-cylinder 260cc gas engine. It is way overkill for this. Even some of the other radials that I've seen put in this online are not quite as big in displacement, but my friend is a machinist, and he appreciates the machine work that has gone into this particular engine, and that is why he chose it. It is a beautiful piece of machinery. All of the push rods being exposed and clicky-clacky with the rocker arms and everything. I mean, this is an absolutely stunning piece of machinery, and it is showcasing on the front like it should. That being said, additionally, there will be a spinner here. There will be a back plate that will space out the prop a little bit further by like at least 1/8 of an inch. I believe we calculate a little over 1/8 of an inch. So we should be able to clear this edge of the cowl just fine. You can see that it's going to be a pretty close fit. Pretty close. It's going to be nice. Very clean install. I used the measurement of the DA 200 to figure this out. So it bolts with a spacer directly to the firewall box. And so I was using that measurement to build a custom motor mount spacer, etc. So I've sandwiched a whole bunch of aircraft grade ply, and I've sandwiched it using epoxy, 30-minute epoxy. Now that's all fine and good. I understand that not all of the layers of the aircraft ply are adhered using epoxy. However, I'm doing the best that I can. In addition to each of the, let's see, 1, 2, 3, 4 layers of plywood, 2 different thicknesses. There's 1/2 inch and then I think a 1/4 inch, 1 layer of 1/4 inch. Once everything was epoxied together and in place, I drilled and put hardwood dowels, basswood dowels. So those were epoxied in place. And what the dowels do is they help mitigate the torque, right? So it helps spread the load of the torque. And so you don't rely solely on the shear of, let alone the layers of the ply, but also the epoxy, which can get quite brittle. It's really strong, but it can get brittle. With all the vibrations, this is probably going to be a really smooth running engine with 7 cylinders. It's not going to be like a single banger. Usually the more pistons that you have, the smoother ride you get. But yeah, had to make that custom, and that was where the vast majority of the work was. The whole thing was smeared with some finish epoxy, and then I coated it with black enamel paint. Yeah, that way just try to keep the fuel off of it. Shouldn't have to worry about fuel at all. There is a rubber grommet stopper for the hole that goes through it. I made sure that there was a hole just in case something needed to happen later. But yeah, the 1-inch rubber grommet is there in order to make a passer if you need it. But generally we'll run the fuel tubing out the side of the box right here, this part. So that's the way they did it in the instructions. So we can just run it out the side straight up to the inlet right there. If you can see that, it's right that little brass nipple right there. That barbed nipple. Okay, so yeah, I had to work out the throttle linkage here. Let me move that just using the servo. Can you see that? It's right down there. Right there. Okay, that's the throttle. And then choke, we just decided to do a simple manual choke. So there's the choke right there. And there's a rod that comes out the bottom. So pull is choked, in is not choked. And you leave it choked so that stuff doesn't get inside the carburetor. All right, so with that said, we've got hardware. I'm using stainless hardware, again, to prevent rust, corrosion, things like that. I've got stainless bolts. These are 1032 bolts mounting the engine to the plate, and then again 1032 bolts mounting the adapter to the firewall box. Now, the way that the engine is cooled is obviously through air, but the way that they designed the airplane is because they streamlined this cowl. Normally on a Waco, there's a space around the edge that would allow the air to exit. So the way that they worked around this is big hole. So you've got all the air rushing in to cool the engine, and then it runs through the bottom and running through the bottom, and then eventually I'm going to cut that open. So we have an exit point for all of that air. To be clear, this is not my design. This is the design of Extreme Flight, okay? I have seen a number of people implement their large engines on this, and they're not putting any cooling holes in it. And I'm like, how is your engine not overheating? But given the complexity of this particular engine, and I know how they can be kind of finicky, yes, absolutely, we had to plan for cooling. So that hole will be cut open as soon as it's ready to be cut open. For now, it's fine. We're doing all the other ancillary stuff right now. Let's get into the ignition system. The ignition box, obviously 7 cylinders, require 7 wires. And so we've got the ignition box mounted up here up top. We've got a piece of Dubro foam, and that should work just fine. I've got some cable ties that have holes, additional holes in them that I could screw down using some screws from Dubro as well. And I've got some loom coming to loom up all the wires. You got your standard tachometer out, as well as power in, and then your LED indicator. So that's what it, and this is your RPM sensor, or your essentially crank position sensor. So it goes down here, and then this wire comes around front. It's here in the bottom. Here's your crank position sensor. So that way the engine and the ignition are talking to each other. So other than that, heat management will be the order of the time, and we will do some test flying and making sure that we're not pushing the engine too hard, and see where temperatures are with an infrared thermometer. An IR thermometer is almost a given, just because you need to spot check things immediately in a number of different locations. Typically, the part where the spark is going to be the hottest part of the cylinder, but you're going to want to check like the crankcase, as well as other points of the cylinder, as well as multiple cylinders. You might find that one portion of the engine is hotter than the other based off of airflow properties. We may have to baffle this engine. Don't know yet, but we'll cross that bridge when we get there. Again, because this isn't the engine that's intended for the airframe, it's a bit of a trial and error process. So with that, I will continue to keep working on that, keeping in mind a lot of these things that we have to address later. It'll become a checklist for sure. It's just so darn pretty. It really is. Ugh. Nice piece of machinery. Okay, so this is going to swing somewhere between a 32 or 34 inch prop. Don't know what he's decided yet. We might go with a 2-blade prop. 2-blade props can be kind of noisy. This isn't going to be exactly screaming at high RPM. So we might go to a 3-blade prop to get smoother air and quieter. But again, that's his call. It's kind of a catch-22. Because I mean, you don't want it to be too smooth. You want to hear the prop rip a little bit on a performance plane like this, but really the star of the show is the engine, and you want to hear the engine. So yeah, not my call. So that is to come. I also wanted to make note that I've got a Teflon exhaust extension coming out. I told you I cut a hole in this fiberglass, and the Teflon tube I had left over from the last UMS project that I worked on for another club member. It's just, I mean, it's huge. I mean, absolutely massive piece of machinery. So at this point in the conversation, we have to talk about next steps. So really next steps are to get the pull lines done for the rudder, and then I'll be handing this back over to my friend. He's going to be wrapping up the wings. It's kind of the easy bit. It's just a lot of linkages and epoxy a couple of pieces for the interplane struts, some wiring, and then a lot of radio programming, and I'll help him with that. It should be pretty straightforward, not too terribly difficult there. And then checking the center of gravity, of course. I'm pretty sure we'll be okay on center of gravity. We may have to end up adding weight to the tail. That's okay. But yeah, we've got to get the fuel system plumbed. Got to get all of the wiring installed and tidied up, get receiver installed, battery systems. Yeah, there's quite a bit left to do. Even though this is basically a finished airframe that you're assembling, there's a lot of little things. You look at these airplanes like, oh, that would be easy to put. There's so much more paying attention to little tiny detail. Did you put thread lock on that? Does this align properly? Is this the correct angle? Are you cross-threading? Lots of little tiny things on this, because one wrong move could be a safety issue, or replacement is really expensive issue. Okay. So it has to be done carefully and precisely. So one little thing at a time, and then you walk away. one little thing at a time, and you walk it. You think ahead. You think through the process several times before you do it. You read instructions. You read up online what other people have done, all right? This is not a trivial task, and I am honored. I am honored that my friend trusts me with this project to help him. But it'll be good. With that, we're going to wrap things up. Thanks so much for tuning in today. Make sure you head on over to dobro.com. I have been using Dobro parts on this project as wherever I can. Screws, bolts, foam, anything I can possibly get my grubby, stupid mitts on to help my friend get his project in the air. So until next time, continue working on your friend's flying work of art.